All right, welcome everybody back for another live stream. My name is Brian McLogan, and I am here to cover polar equations. So just to give you a roundup, if you've been following my class this year, this is a homework assignment that I gave to my students, and we have a quiz the next few days to round out the week. So I wanted to make sure that I went over, I'm not seeing my stream life is coming in. Very good. But this is a homework assignment that I gave my students to prepare for their quiz. And we will kind of go through them. So I do see my live stream. I'm not sure why it's not giving me a good stream health. So just kind of looks like you guys are in the chat, so it looks like everything is working the way it is. I'm not sure what YouTube's going on there, but hey guys, hey, looks like Jan, Ozzy DX, and Sizzy La Loca. How are you guys doing? So what I'll do is I'm going to kind of work through these points. You can see we covered some polar equations. We didn't get really in depth with like the graphs of polar equations. That's not something I've really taught in the last couple of years, just because it's not really something that we really have time to involve ourselves with, and at least preparing for the kind of end of the course. So what we're going to work on here is just converting rectangular points to polar points, converting polar points to rectangular points, finding three different representations, converting rectangular to polar, and converting polar to rectangle. So this is like really everything we covered in class, and this class was kind of a fast pace, so hopefully my students are taking advantage of completing the homework on this, so therefore they get that practice and that repetition, because that's not really something we had enough time in class. So hopefully they are watching and practicing on their own. So that's what I'm going to kind of work for. What I'll do again, guys, is the same kind of live stream format. I will work through these free response. Then I'll take a quick little break, and then I'll answer questions for you guys on the multiple choice. And then also if you guys have some, different troubles with like complex solutions, I see Agnes is asking on polynomial functions, then just go ahead and type it in the chat after I am done with my homework, and I'll be more than happy to kind of answer some questions as long as I have some time. But so if you have some questions, just wait till I'm kind of done with the stream. If you have questions based on what I'm talking about, then obviously let me know about them in the chat, and I will get through them. All right, so just a reminder, guys, this is a homework assignment, so we've already kind of covered how to do these problems, so my explanations are not going to be as introductory as maybe some of you would need if you're first learning this stuff, but hopefully some of you that are following have either gone through this topic or are going to go through this topic by the time you watch it, so you kind of have a general idea of what we're talking about. All right, so the first one, oh, crap. Oh, gotta have my handy little calculator. All right, so the first one says convert the following rectangular points to polar points. So just remember when we're looking in rectangular points, let's zoom in. So rectangular points is what we are familiar with. That is in terms of x and y. And then polar points are points that are in terms of r, which is the radius or distance away from the origin, and then theta, which is theta in standard form. And I just kind of focused on radians, but you could deal with radians or degrees. So let's just say it says convert the following rectangular points to polar points. So how is the relationship here from polar points to rectangular points? Well, again, I'll just kind of do a little introduction, I guess. On this first point, we have 3, 3. So 1, 2, 3, 1, 2, 3. So here's the point 3, 3. Now, again, to understand polar points, we need to figure out the distance it is away from the origin as well as the angle, theta. Well, based on this, we know the height and the distance away. Like that's 3 and that's 3, right? So to find r, we can basically just use the Pythagorean theorem. R squared equals 3 squared plus 3 squared. So therefore r, so 3 squared plus 3 squared is 9, so it's going to be 18. So then take the square root of that. So r is equal to the square root of 18. And then if we needed to find theta, we can just set up the equation. Let's see here, kind of running out of space. Let's put up here. Tangent of theta is equal to 3 over 3. Well, hopefully you guys recognize that when you're doing theta, tangent is going to be tangent inverse of 1. And hopefully you guys recognize this is a 45, 45, 90 triangle. So therefore, that's going to be 45 degrees if your calculator is in degree mode. In this case, we're just going to use radians. So that's going to be pi over 4. So therefore, now to write my point in polar form, that's going to be the square root of 18 and then pi over 4. And I didn't say to address that, so I guess I should probably make sure I clarify that on these. All right, the next one is negative 4 comma 0. Well, again, like we can kind of even look at this one. This one's kind of easy. 1, 2, 3, 4. So how far is this away from the origin, or from like the origin? Well, it's 4. Again, it's positive 4, right? Because it's 4 units away, or 4 kind of circles, as we kind of looked at the polar points. And then, like, what is the angle? Like, what is the angle in standard form? Well, we could just say that's pi. All right? Oh, that might be an interesting one to use. Okay. The next one is 1 comma 2 square root of 3. Now, this one doesn't look as nice to be able to simplify here. But again, we can kind of use the same idea. We know that r squared is going to equal 1 squared plus 2 radical 3 squared. So here I'll just do a little bit more work here. So 1 squared is 1. 2 radical 3 is going to be 2 or 4 times 3, which is 12, plus 1 is 13. So therefore, r is equal to the square root of 13. And then if we want to figure out the tangent here, I'm going to have the tangent of theta is equal to, let's see, if we were to graph this, this would be like over 1 up 1 square root of 3. So that's going to be opposite to square root of 3 over 1. Now, let's see, if I divided, that doesn't seem like that's one that's going to work out there. So I think I messed up that point, at least as far as radians. So, because I think this was supposed to be, that's supposed to be just a 1 square root of 3. So how should I change this problem? Let's change, well, let's just do it as it is. So then theta is equal to the tangent inverse. However, I'm going to want to put this in degrees because, my calculator's in degrees. So if I did the tangent inverse of 2 radical 3. So let's go and see what that gives us. So I do the tangent inverse of 2 square root of 3. And that's going to give me 73.8 degrees. So theta is equal to 73.9, I'll say that, degrees. So I didn't really clarify in the homework, so that's my apologies. I should probably make sure I adjust for that. But, in finding radian, if you did this in radian form, you would get the similar answer. It's just going to be a decimal. I think what I meant to do for this problem is I meant to give this as your polar point. So therefore, you would recognize, therefore you would recognize that would have been square root of 3 over 1, and the tangent of square root of 3 would have been pi over 3. So I believe that was the answer I was searching for. But either way, we can adjust. It kind of, if this did, happen on a test, we could still just use our calculator. But if we were going to do it in degrees, let's just do the degree format. And then if I was going to change my calculator, I might as well just do it in the radian mode. And then just do, can you do second entry in this one? No, I guess you cannot. So I'll just retype it. So tangent inverse, and that is theta equals 1.29, and that's a radian. Okay, so just in case my students are checking their work from there, if you had to use your calculator, I don't think that was intended, but we'll just have to roll with it. All right, so convert the following polar to rectangular points. So in this case, I think it's helpful for us to kind of understand, where these points are, where they kind of are located. So what I'm going to do is I'm just going to graph one big XY axis, and then hopefully I can plot all these points on the XY axis. So basically, polar graph is the XY axis with kind of circles representing the distance away from the origin. And gets a little hard doing it with that. So let's see, 1, 2, 3, 4. Cool. All right. I don't know why I picked the hardest problem first, so let's move to this one. So 3 represents a distance of 3 units or 3 radiuses or 3 units away from the circle, and then at an angle of 3 pi over 4. Now this is really not part of the point, but I'm just going to draw it here. The angle 3 pi over 4, remember, is in the second quadrant, right? And therefore the point then at 3 units away at that angle would be 1, 2, right here. So I'm just going to label this. So there's that point. Now, if I need to figure out 3 different representations, this is to convert to polar points, rectangular points. So, I don't know, I was thinking 3 representations. There we go. So, to convert this, that's actually not that bad then. To convert these, there is a kind of rule. So, basically converting from rectangular to polar, we looked at basically using the Pythagorean theorem and then using the tangent function. Well, to convert from polar to rectangular, we basically have these 2 equations. X equals r cosine of theta, and y equals r sine of theta. So in this case, that's really basically all I need to do. I have an r, right? That's my r, and that's my theta. So as long as we know our unit circle, we're kind of good on this one. So you know what? I'm going to get rid of that graph. Hopefully, I'll leave it there because that was at least a good review for anybody that's watching as far as polar graphs. So in this case, I have x is equal to -2 times the cosine of 3 pi over 2. Well, remember, guys, 3 pi over 2 that's going to be on the y-axis, and the cosine is the x-coordinate, which is going to be 0. So that'd be x is equal to 0. And then the y-coordinate here, y-coordinate would be -2 times the sine of 3 pi over 2. Well, again, 3 pi over 2 here for that coordinate is going to be -1. So y would equal -1 times -2, which would be a +2. So therefore, we have our coordinate point in rectangular form is going to be 0, 2. All right. To the next one, we're basically just kind of doing the same thing. So yeah, let's just do it. X equals 3 times the cosine of 3 pi over 4. Cosine of 3 pi over 4, that is in the second quadrant. So again, like that coordinate point is, so this point is negative square root of 2 over 2, comma, square root of 2 over 2. Now again, don't worry about the radius, because that's the point for like right there, right? Negative square root of 2 over square root of 2, but now we're multiplying it by 3, which is basically like a scalar that we've kind of talked about in class. So again, this is negative square root of 2 over 2 times 3. So that's going to give us x is equal to a -3 square root of 2 over 2. And then we have the y. That would equal a +3 times the sine of 3 pi over 4. And that's going to be then, sine is positive times 3, so that's going to be 3 square root of 2 over 2. Okay, so then our coordinate point, which I kind of did not leave enough space here, is just going to be a negative square root of 3 over 2, comma, 3 square root of 2 over 2. There you go. Looks like the stream health is back a little bit better, so cool. All right, on to the last one. As you guys can notice, I kind of just knocked all of them in from there, so we're just following the same pace. This one I'll actually break down so you can see where I'm getting those points because I have a little more space. So x is equal to 4 times the cosine of 7 pi over 6, and y is equal to 4 times the sine of 7 pi over 6. All right, so 7 pi over 6, let's kind of graph that. Like 7 pi over 6 is down here, right? So that coordinate point here is going to be, let's see, that's 7 pi over 6, so that's going to be in the third quadrant, so the x-coordinate is negative, so that's a negative square root of 3 over 2. Did I make a mistake with that? No. Okay. Negative square root of 3 over 2, and then that's going to be comma 1/2. I just thought I had, yeah, okay. And then, obviously, so that's that coordinate point. So therefore, x is equal to 4 times the cosine, which would be negative square root of 3 over 2. And then the y. Oh, did I make a mistake? Oh, wait. I wrote that wrong. Huh, I got to fix that answer. I was like, something doesn't seem right. That was a -3 square root of 2. All right. So in this case, my y coordinate is 1/2, so that's going to be 4 times 1/2. All right, so therefore you can see x is equal to, you can do 4 divided by -2, so that's going to be a -2 square root of 3, and then y is 4 times 1/2 is just equal to 2. So we can write this coordinate point as -2 square root of 3, comma 2. Okay, now again, if you wanted to plot this point, we have the angle here. That is the coordinate point, basically negative square root of 3 over 2, comma 1/2. But if we add like 4 circles there, that would be your coordinate point, like down there. Same angle, but now just kind of 4 radiuses over. All right, so now the next one is getting into the 3 different representations. And when doing the 3 different representations, I am going to include one positive, one with the positive radius as well as one with the negative radius. And this was something that, is very difficult to kind of like teach with the students. I think it would be something better, kind of spent like with an investigation so students can really see, how this applies. We just really kind of ran out of time with this, so we didn't really have the opportunity to be able to do that in class. But I think the main important thing is looking at this as far as just plotting this point. Like, where does this lie? So this lies at 1, 2, 3. Okay, so there's 3 rings out, 3 distance away, and then it's at pi. So if I want to do one representation, I could just do 3 comma negative pi. Right? And then I can add and subtract 2 pi from both of those. But you know what? Let's have fun. Let's go ahead and find the 2 negatives, what the negatives would be. And the easy way to kind of think about this is, really, if you're going to do like x equals r times the cosine of theta, well, think about this. If you're going to do cosine of pi, right? Cosine of pi is -1. Cosine of negative pi is -1. So when you multiply that by 3, you're going to get 3 times -1 and 3 times -1, which is going to give you -3. Now, if you look at this point over here, that is the cosine of 0, right? That's 0 degrees. So the cosine of 0 is +1. So if I multiply -3, so if I change this to 3 times the -3 times the cosine of 0, what you guys can see is that's going to give you actually the same point, right? Because what is the cosine of 0? 1. 1 times -3 is -3, which takes you back to that point. Now, actually, I'm not really sure if there's, I guess I could do -3 and I could add like a 2 pi, right? That's another representation. So there's 3 representations right there. All right. Now, when we have a -1, this one kind of gets stuck. So a lot of students had trouble with this. I said, you know what? Slow down. Here's an easy way you can kind of just think about the reflection. And what I did is I broke them down into vectors. I said, guys, if we can graph, this vector 2, 3, that is the vector 2, 3. And you know what? If I multiplied that by a negative, I would now get the vector -2, -3. So when you have a scalar on the outside, which is basically your r, your radius is represented as a scalar, that is basically just reflecting this graph about the origin. So if you want to graph this, let's remove the 2, right? And remember, this is polar form. When you're looking at rectangular form, you could also think of this as r cosine of theta, comma, r sine of theta. Right? So you can factor out that r. So r is a scalar. It's really cosine of theta, sine of theta. All right? So forget about the r for a second. Let's just graph where the angle is on the unit circle. Right? Let's pretend r is 1. So if I'm going to graph this, 5 pi over 3, that's going to be in the 3rd quadrant. On the unit circle, let's make it even bigger. So 5 pi over 3 is going to be right here. All right? Now, it has a radius of 2. So now let's change r to 2. So that means it's going to be on the 2nd ring out. Right? So now it's 2. Now again, if we're going to be multiplying this by a -2, that means it's going to be reflected about the origin, just like we would have done here. So even though these lines are not really a part of the graph, I'm going to use them so we can see why we get this reflection point, which is right here. So -2 5 pi over 3 is right there. That is the point. This is your point. This is your point 2. 5 pi over 3. So again, remember the negative, you got to think of that as like a scalar vector. That is going to reflect it about the origin. So that is our coordinate point. Now, let's go ahead and figure out, well, if that's the coordinate point, right? All right, cool. So then what is your reference angle? Well, here the reference angle is pi over 3. That means that is your reference angle, pi over 3. So if we had a positive radius, so we could do positive radius, well, that's pi over 3 short of pi, so that's going to be 2 pi over 3. And we could do 2 comma the negative version, which would be pi over 3 over pi, which would be 4 pi over 3, so negative 4 pi over 3. And if we also want to do the negative version, instead of doing 5 pi over 3, we could do negative 2 negative pi over 3. So those are your 3 representations. All right, last but not least here, let's go ahead and knock out this last one, 1 comma pi over 4. So if we, basically we could just add and subtract from this one. But if we were to graph this, obviously this is on the unit circle. And again, here's actually like a good idea. We know 1 comma pi over 4 is right here, right? But like over here, like we know pi over 4, like this coordinate point is square root of 2 over 2, comma, square root of 2 over 2. This coordinate point is negative square root of 2 over 2, comma, negative square root of 2 over 2. Right? So it's interesting when we have this, when we multiply, when our r is negative, remember that's reflecting it about the origin. So if you multiply both of these times a negative, you get that point basically. Right? So you can see how multiplying one of these points by a negative, it distributes it too, right? It's like negative times both terms, and that's why it turns them to the exact opposite. So it's that reflection about the origin. So let's just kind of quickly do for this. If we have pi over 4, let's do the negative version, which would be negative 7 pi over 4. This angle down here is going to be, and positive version would be 5 pi over 4. So we could do negative 1 5 pi over 4, and then we could also do negative 1 comma negative 3 pi over 4. So there you go. Hopefully it kind of made sense for some of you guys. I think I'll need to kind of do a little bit more of an investigation for that, for students to really kind of like understand that concept. The next one says, convert the following rectangular to polar equations. So when we're converting rectangular equations to polar, we basically want to get rid of x's and the y's. And there's 2 ways we could get rid of x's and y's. One is we knew that x is equal to r cosine of theta. So whenever we saw a x, we could just replace it with an r cosine of theta. Hey, guess what we got? An x. So let's replace this with an r cosine of theta. Now, it is no longer written as a rectangular equation. It's written as a polar equation. On a multiple choice test or quiz, it probably is not going to be written like that as an answer choice. So we could divide by cosine on both sides. And instead of writing cosine in the denominator, we can use the reciprocal function, which would be a negative 3 secant of theta. For this one, we have an x and a y. Well, that's kind of interesting because if x is r cosine of theta, y is going to be r sine of theta. So now I can just rewrite x as 2r cosine of theta plus r sine of theta is equal to 2. Now, that is a polar form. That is perfectly fine. However, on a multiple choice, you could factor out that r. You'd be left with a 2 cosine of theta plus sine of theta equals 2. Divide by that quantity if you wanted or if you needed to solve for r. And you'd have 2 cosine of theta plus the sine of theta. All right, so for the last one here, if we replace the x and the y, that's fine, but then we're going to be squaring things, and I'm not really sure if I want to be squaring sine and cosine squared. We could, but in this example, we can see that we can expand this, right? We can expand x minus 1 squared. So we can expand this in the head to give us x squared minus 2x plus 1 plus w squared equals 1. If I rearrange the x squareds and the y squareds, what I notice here is that's kind of similar, right? We did this before. Where was that? Oh, I guess I didn't write it out there. But the components, I didn't write it anywhere. The components, x squared plus y squared is equal to r squared. So we can rewrite x squared plus y squared is equal to r squared. And then here we can write this as x, that would be 2r cosine of theta. And then if I subtracted those two, that would be equal to 0. Now, I'm kind of running on some space, so I'm going to throw this over here. Now, I can set the r squared equal to the other side, so that would be 2r cosine of theta. And then I could divide out the r and just leave me with a r equals 2 cosine of theta. So that's basically our idea. Obviously, just to write something in parametric, or to eliminate it out of rectangular form, guys, is just getting rid of the x and the y's. And then typically, if we could go through the extra step, which would be solving for r. And that's kind of the same thing for rectangular equations. Like most rectangular equations, we want to set equal to y. Like that's how we understand them. However, if you remember in parametric equations, that was not always the case, right? And we're going to be studying more of those problems like for circles where we don't need to solve them for y. We just leave them in terms of x's and y's, and we can understand what the graph is. But we're going to investigate those a little bit more later. For right now, we just want to convert from polar to rectangular equations and then classify the graph. So we see if we can determine what the graph is. So now we want to get rid of the r and the theta. All right. So last time to get rid of rectangular, we want to get rid of x and y. Now to get rid of polar, we want to get rid of r and theta. So again, kind of using our understanding here, to get rid of r, we need to have it either multiplied by cosine or sine, or we need to have it squared. Well, in this example here, I don't want to multiply by an r on both sides. That would give me an r squared, but that's not going to get anything there. I don't want to multiply by cosine on both sides because then I'm going to have a random cosine on the right-hand side. So one thing I can do is just square both sides. When I square both sides, I get r squared is equal to 25. R squared, remember, is x squared plus y squared. Okay, and hopefully you guys remember that this is a circle, so that would be our classification. It is a circle with the origin, with the center at the origin and a radius of 5. The next one's kind of simple here. We already have r sine of theta, so let's just replace that with y. Now I no longer have an r to theta, and I have a y equals 5, which is a horizontal line. All right, and the last one here, guys, is r equals 12 cosine of theta. So squaring them is not going to work. I don't have an r times the cosine of theta. So, however, if I multiply both sides by r, and I just put the r in between the 12 and the cosine, I get r squared is equal to 12r cosine of theta. Well, r squared is x squared plus y squared is equal to 12x. Now, we might not know how to classify this, so I showed this to my students in class just to kind of remind them because, again, this is really a precursor for what we're going to be doing next chapter. To really classify, to understand this, I can group my x's and my y's together, so I can bring the 12x over. And then I can complete the square. So remember, completing the square is taking your b term, dividing it by 2, and then squaring it, which equals 36. So therefore I have x squared minus 12x plus 36 plus y squared. Now remember, you added 36 on the left side, so therefore we have to add 36 on the right side. This can be broken down in, or this can be factored into x minus 6 squared plus y squared equals 36. So you can see this is actually very similar to the other equation that we had. This is going to be a circle with a radius of 6 and a origin at 6, 0. Now I didn't ask you to do that. I just kind of said, determine what that equation is, which in this case is a circle. So there you go for that. Now let's just go ahead and take a quick little break. See, some of you guys have joined on. Let me zoom out. Happy to have you guys in. For on this merch, I got to get through this. What's up? Help us so much. You're very helpy, Juicy Jake Studios. Hope at some point somewhat enjoyable. Oh man! All right. Wow, a lot of comments coming back up in here. You are very welcome, Austin, to help you out with your homework. Hi, Anson. Hi, Ronnie. Game Boy, you are my math bone. All right. Sweet. All right. Well, I'm not sure if there's any questions, guys, but if you do have some questions you would like me to take a look at, then now it would be the kind of time for you guys to start asking them. I'm not seeing if there is. Not seeing if there's anything, any questions for what I have covered at least so far. Because the example is 3, 3. Yeah, that was a 35, 30. But why is it square? Why couldn't it just be 3 plus 3? What was your question? Why is r squared equal that? Oh, see, Anson was asking the question, so I should provide that. Yeah, so let me write that in there. So remember, r squared is equal to x squared plus y squared, right? That's basically the Pythagorean theorem. So in this case, my x and my y were both 3, so that's how I got that. But thank you for asking that question, so therefore I can clarify, because, we did cover that in class, so I was kind of moving a little bit fast for you guys. So I appreciate that. So Agnes, if you're still in, I'll be happy to talk about complex numbers for polynomial functions. And however, answer things. There you go. Hopefully, Anson, you're still here. Hopefully, I answered your question. I appreciate you asking, because that is how you learn, is asking questions, not feeling like stupid because you don't understand something, but ask, and then, you can see where it opens. All right. Arizurf, how are you, man? Good to see you. Good to see you back. Hopefully, I can help you out again with any questions you guys have, but let me get through this multiple choice here real quick, and then hopefully I'll have some time to answer any questions or chat with you guys about anything done. But let's go ahead and focus on getting this over with. You can see now I have a polar point that are, I have a polar point that's now using degrees. But again, guys, it's the same thing. We're going to use x cosine of theta. X equals 9 times the cosine of 120 degrees. And y equals 9 times the cosine of 120 degrees. Now, I can tell you a couple things already. 120 degrees is in the second quadrant, right? So I know cosine is going to be negative, and I wrote that wrong. That's supposed to be sine. And the sine is going to be positive. So just using my intuition here, I already know that this has to be negative and positive. Positive, negative, that doesn't work. Negative, negative, that's the third quadrant, right? That's third quadrant. That's the first quadrant. That's the fourth quadrant. So the only one's the second quadrant is the first answer. So I'll plug this in my calculator just to make sure. You're going to want to make sure that you're back in degree mode if you changed it while working on the problem like I did. And let's do 9 times the cosine of 120. And I get 4.5, which would be negative 4.5, which is negative 9 divided by 2. So there you go. Confirm my answer, but that's the nice thing about having a calculator. So the next one is convert the rectangular point to polar form when we're given negative 1, 2.6. So again, this is a rectangular point. So remember like what we just talked about, or at least what we had answered had a question on, like r squared is equal to x squared plus y squared. Well, so therefore r squared is equal to negative 1 squared plus 2.6 squared. So r squared is equal to, let's see here, negative 1 squared is 1, so we'll do 2.6 squared plus 1 is 7.76. And then r is going to equal the square root of 7.76. Square root of that answer, and I get 2.79. And again, we got to think about this, like which quadrant is this in, because you have this plus and minus, right? So we kind of want to understand this a little bit. So this is negative 1, 2.6. Okay, so let's just go with a positive radius here. Let's make sure this answer is valid. Let's go with the r is 2.79. Okay, so if it has a positive radius, right, that means my angle should be in the second quadrant. So as long as there's an answer choice for an angle in the second quadrant, which is not this one, not that one, not that one, I have an angle. So it looks like this one's going to kind of work, but let's verify what our angle is. So again, our angle is going to be the tangent of theta is equal to 2.6 divided by negative 1. So theta is equal to tangent inverse of negative 2.6. So we go ahead and tangent inverse, and we're in degree mode, right? Okay. So tangent inverse of negative 2.6. Okay, so I get negative 68 degrees, 68.9 degrees, which is down here, right, which is basically giving me this angle. So I know that that is going to be that rough angle, that same angle. So negative 68.9 is what my calculator gave, because that's because my calculator is restricted in the first and the fourth quadrant. So really this angle is 68.9 degrees, or 169. And if I do 180 minus 69, I get 111. So I can confirm that A is going to be my answer, because if that's, let's just rewrite that. So let's just do these as whole answers. So when I do my calculator, I get 69 degrees, which is the same thing as 69 degrees. So therefore, that's 111 degrees. So you can see that angle is which is in your standard form. All right, number 3 says find an equivalent equation in rectangular coordinates. So here we have r equals sine of theta. This is going to be kind of similar to the one we did. We're just going to multiply by r on both sides. So therefore I get 10 r sine of theta. R squared is x squared plus y squared is equal to 10 times y. And looks like that equation is right there. So boom, not going to have to solve for y in this case. Like that's not an ideal. We'll just leave it just like that. And this next one here is find an equivalent equation in polar form. So remember, x squared plus y squared, guys, is equal to r squared. Minus 4x, well, we can write x as 4 r cosine of theta, equal to 0. And then it looks like they don't have anything exactly, but if you add the 4r cosine of theta to the other side, I get r squared is equal to 4r cosine of theta, which is, let's see, do I have one of those? I'm not seeing this alpha. Oh, and then you could divide by r. So r equals 4 cosine of theta. And there you go. There's that answer. So in this one was a little bit difficult because you had to kind of manipulate those equations a little bit. So hopefully that helped you guys out for those of you that are getting into polar equations and polar points. Again, I don't cover the graphing in this homework, and we're coming up with our test and our spring break, so it's just not really something that we were able to kind of fit in. So I apologize if that's something you guys had questions, but let's see. I got a little bit of time. If anybody has some questions, I'll be more than happy to help you guys out. I'm kind of tired today. It's been a long week. I had a lot of direct instruction that I had to do, which just makes it tiring, especially teaching only pre-calculus this year. It's just a lot of covering the same thing over and over. So I am looking forward to a little bit of giving some quizzes and reviews and tests. So therefore I can just kind of decompress from teaching mode a little bit, because obviously then we're going to get into the fourth quarter. A couple things I'm going to work on. I have a review for pre-calculus that I look forward to sharing with you guys. I'll look forward to doing a live stream. It's a big review. I mean, it covers the whole class. I think it's like 130 questions. So that's going to be a long live stream. I'll probably have to break it up like I did before into like 2 live streams, but yeah, it's definitely going to take like more than an hour, maybe 2 hours, maybe 3 for me to cover that. But I'm looking forward to it. I don't know. I might probably do that like on a weekend or something. And then obviously for those of you that want to follow along with that, you guys can go and do that. But yeah, so those are things coming up. All right, so let's go and see. D'Angelo just got into m minus. All right, aren't we supposed to draw the graph? Zarif, what are you talking about drawing the graph? You could. We haven't, or maybe we're talking about polar equations. Yeah, so we looked at graphing these in polar equations. We looked at kind of graphing these. We haven't really, I I was hoping my students remembered graphing circles from geometry, but they kind of gave me that blank stare. They didn't remember anything from there. So I said, you know what, don't worry about that. Next chapter, we're going to be covering conic sections, analytic geometry. So we're going to be doing the graphing circles, parabolas, ellipses, hyperbolas. So I'm not really worried about that. I just wanted to kind of expose them to that and kind of seeing a lot where these equations come from. So that's why we didn't really get too much into the graphing portion of this, because we're going to be doing it all next chapter. All right, so D'Angelo has a question, but I'm not sure what is your question. What are you asking to do? Are you like, what is it? And I think also if you could maybe, it'd be helpful if you provided some parentheses, but I'm assuming your question, and you can correct me if I'm wrong, but next time when you write in, just use some parentheses to make sure. But I believe, let's see, this is a rational problem. And I'll go back if any of you guys else had a question before. So that's m minus 5 divided by m squared minus 7m plus 6. And I'm assuming that's plus that's going to be plus 2m plus 1 all over m squared minus 5m plus 4. Okay, so confirm with me, D'Angelo, that that is the one that you're looking on, and then I'll confirm that, but I believe that's kind of what we're going on. That looks about right. What grade should you have in pre-calc to do well in calculus? That's a good question, Keith. Really, I kind of tell the guidance counselors, at least my class, like, really any student that earns at least a C, like a decent passing grade in pre-calculus, I think can do well in calculus. It really kind of depends on like what you feel you've understand or like took away from pre-calculus. Obviously there's kids that have received C's in my class that have an understanding of the concept. They maybe just didn't do as well on tests or quizzes or did the homework, but they have a general concept of understanding, and they're going to do fine in calculus once, and as far as the understanding concept. Because contrary, I also have students that have B's, and maybe not really as many A's, but some B's and C's that really don't understand the concept very well, but they really just kind of focus on doing well on tests and quizzes, but don't really learn to actually learn. They just kind of want to do well in the class, so they don't really understand what we're actually doing and why we're doing it. So then they're going to get to calculus, and it's going to be another struggle for them. So obviously you can't, not everybody's the same. But I usually kind of say, if you've earned a C, you're probably missing some content. But again, like I said, that could be somebody that has a B that really just really good at taking tests, and they still don't understand it. So I say, as long as you've earned at least a C to an A, you're going to be doing fairly well. But, C can pose some questions. If you're going to C, that means you've missed some problems on tests or quizzes. That means you have some holes in your understanding. A kid that got a D for certain reasons could do well in calculus as well. Could just be somebody that, had some unfortunate events that got the grade. But I think as long as a C or higher, preferably a high C to a BA is going to prepare you the best for calculus. But I don't think there's like one grade or one average, just because every class, every teacher, every student, there's so many variables to determine what's going to help you be prepared. Brandon, I'm assuming you want me to simplify or to verify that identity. And I did identities like that. I can't remember. I'm trying to think, Brendan, what you'd want to do. Cosine of X or sine of X. We didn't do problems like that this year. And there's a really simple thing to do. I just cannot remember off the top of my head. Cosine of X or cotangent of X, sine of X minus sine tangent of Y. I can maybe play around with it. We'll see. Actually, I'm not going to have time for that. Sorry, Brendan. I'm not going to be able to get you your verified identity. It's just going to take me too much time to think through it. It is a great question. Not sure how you find the LCD, the leading I'm not sure what your question is. What's the LCP? I have a college calc exam tomorrow, and I'm literally binge watching your videos. I've learned so much from you than the $2,500 class I'm taking. Well, I am very sorry you've had to pay for a class. That is not very helpful, but I am very happy that all of my videos for calculus have been able to help you out. So keep it up. Life is beautiful. Least common product. Okay, I don't know. I don't teach as far as on that way, as far as the least common product. So I'm not sure. Are you looking into verifying that identity though, Brendan? That's what I was kind of like confused on. Is that's what you're trying to? I'm assuming that's what you're trying to do is verify the identity. That's something I'd have to maybe work on later, but it will. It's not something that like pops up to me because we haven't covered those in a couple of years. So I kind of I remember I was doing a problem similar and I kind of forgot. But either way. Thanks so much, guys. All right, so let's at least do this rational expression. This is a very common problem that a lot of people have, and then will go ahead and sign off so I can finish off the things I need to do because I don't have that much time left in my stream for you guys. But let's go and knock this out because this is one that I think a lot of students from calculus, algebra 2, pre-calculus, get struggled with. So the main idea here, guys, is we see some quadratic trinomials. Let's factor them, right? So we automatically see that, let's just write this. In the factored form, I can rewrite this in factored as m minus 6 times m minus 1. Now, if you don't get that factored form, I am sorry. I don't have time to kind of explain the factoring techniques. We need to make sure, especially when you get into calculus and pre-calculus, that factoring is something of a skill set that you have. All right. So therefore, we can now just kind of rewrite the equation m minus 5 divided by m minus 6 times m minus 1 plus 2m plus 1 all over m minus 4 times m minus 1. So now you guys can see that they have a common denominator of m minus 1, but to get them to have all common denominators, I'm going to have to multiply this by m minus 6 on the top and on the bottom. And then over here, I'll have to multiply by m minus 4 on the top and the bottom. Okay, so now you can see that my denominators are exactly the same. And my numerators are not exactly the same, but now I can kind of like distribute, right? Using Pythagorean theorem, using FOIL here, I can distribute here, and I can distribute for these, and then I can combine like terms. So let's write this all under 1. So my common denominator, again, is m minus 4 times m minus 6 times m minus 1. Over here, m times m is m squared. M times negative 5 is a negative 5m. Negative 4 times m is a negative 4m. Negative 4 times negative 5 is a positive 20. The purple plus comes down. And now let's multiply these two. So 2m times m is a 2m squared. 2m times negative 6 is a negative 12m. 1 times m is a positive m. And 1 times negative 6 is a negative 6. Now, some of this you obviously could have done on your own. And now let's just go ahead and combine all of my terms in my numerator. And my denominator, common denominator, remains the same. All right, so I have m squared plus 2m squared is 3m squared. Let's see. Now the linear terms are going to be fun. So that's negative 9m. And then that's going to be a negative 21m. And then plus m. So that's going to be a negative 20m. Please check my math for me. And then I have 20 minus 6, which would be a positive 14. So it's not really like uniform there. But there you go. Now you could also look into see if that's factorable. But I'm not seeing anything that would work with that 6 and 7. No, that doesn't look like that's going to be factorable. So there you go, ladies and gentlemen. That is basically adding your fraction. So hopefully, guys, that helped me out. Luke has a quick little question. I'll try to see if I can do it without doing it. A question on solving systems by graphing. If you have variables that does not have a number in front of it and it is slope-intercept form, how do you solve that? If you have a variable that does not have a number. So I'm assuming like if you have like y equals 1 and like x equals 5, Well, you just got to graph them. So remember, like y equals 1 is when the y coordinate is equal to 1. So you just draw a line at y equals 1. X equals 5 is a line when x, the value, is equal to 5. So you just draw a line when x is equal to 5. So does not have a number in front of it. Or if you have variables that does not have in front of it. Yeah. So therefore, the intersection point, or the solution, in this case, is 5, 1. Now, you might have asked in one, I think you might have also, I think what you meant, now that I kind of reread this, is y equals like x plus 1. Well, just remember when you're doing slope, you can rewrite 1 over 1. You can just rewrite, let's put like this as a 4. You can rewrite this as 1x plus 4. And then to do slope, which would be like rise over 1, you can do 1 over 1x plus 4. So you're just going to do it the exact same way, and then just graph it with 1 over 1. And that would basically, kind of be it. All right, guys, that is it. Sorry, Luke. So basically, Luke, just go ahead and set it equal to, go ahead and set each one of them equal to x. And I can't really zoom. Yeah, so that's a negative x. So then you're just going to graph these. Like when you graph that line, even if it's a negative, if it's y equals negative x, then just, what do you have? Negative x minus 1. So you can go down to negative 1. Now your slope is negative 1. Now it doesn't matter if it's negative 1 over 1 or 1 over negative 1. No, it doesn't. So go up 1 and then to the left 1. Or go down 1 to the right 1. And there's one of your lines. Now your other line, just solve for y and do the exact same process. But I'm sorry, guys, I'm going to have to sign off for that. Hopefully, at least Luke, though, that gave you a good start. But I teach in Jacksonville, Florida, so enjoy the sunshine and everything like that. But hopefully, guys, this has been great help for you guys on the multiple choice and the polar. Let's see, we're giving a quiz this week, and I'm going to have to go live. So I'll probably go live on Sunday. This time. So I'll try to make sure I put a reminder for you guys, but I'll go live, I think, on Sunday to help my kids prepare for their test. Otherwise, guys, I'm going to sign off. Have a great night.